Share my screen. I hope my screen is visible, right?
Yes, ma'am.
Oh, thanks. Today we have revised the topic of week one content last month. So we will start off with solving problems now, and a few of you have asked some questions from the graded assignments based on the simulation. Since a few of you people are very new to this domain and using MATLAB, so I want you to get familiarized on those things. So we will look those things during the end of this session, and I will try to solve so few basic problems on whatever content we saw. And if you have any doubt, please feel free to ask in between also. That's all. So we have seen contents like hmm, so content we covered would be around open loop systems and types of systems. So under this we have many categories like linear, non-linear, static versus dynamic, causal, non-causal, and time variant versus time invariant. And something else I'm missing. No, if we come across, we will add those things here. Right. So I want to solve a few problems based on this, and I will start up with some simple problem. Find the linear system from the below options. Okay. Option A would be 2t plus 5. B would be t squared plus 5. C is t sin t. D is t1 plus t. Right. From this, you can directly say this is nonlinear since it has trigonometric operations. This is nonlinear since it has squared operation. And we have to check this and this. This seems a little um, way to solve it. The first A option would be 2t plus 5 and D option would be t into 1 plus t. So if I expand this, this would be t plus t square. Again, this is visible that it is non-linear, right? So the linear is A, that is 2t plus 5. Again, if it seems to be linear, right? Here, am I right? Or do you have any discrepancies with this? How a 2t plus 5 would look like? 2t will be 2 into whatever t. For example, if I take 0, 1, 2, 3 as t, then 2t would be at 0, it will be also 0. And when it comes y equal to 2t, I'm plotting. So when it comes to 1, when x is equal to 1, y would be 2. Okay. When x is equal to 2, y would be 4. X is equal to 3, y would be 6. So 2 points for every 1 point that is being jumped from the x-axis. So this I can guarantee that this is a linear relationship. But instead of doing this graphical representation, for that you feel easy with this, I'm doing this. We have to do two criteria: superposition and mm, homogeneity. Okay. We have to find whether the function of x plus x2 is equal to f of x1 plus f of x. And these two are into a into f of. So these two conditions we have to find. And right, when I want to continue this graphical representation, y equal to 2t plus 5 I am taking here. So when it becomes 2t plus 5, it has one deviation at this coefficients, right? This constant jump. Be there. So at 5, when x is equal to 0, y will not be 0, than that y will be 5. So for example, equal to 1, y becomes 2 plus 5, that is 7. When x is equal to 2, y is equal to 2 plus, 4 plus 5, that is equal to 9. So this jump will be there, but it is not linear. See, there is one discretized version here. When you, it's not continuous and it, okay, what happened? It's not continuous and it's not linear. So this would be non-linear. So out of all this option, everything is non-linear. Right? If this term is not there, then it would be linear. Otherwise, it is non-linear. And this, I think, this is where that problem was. That assignment issue was. Right? Okay. Skin. How can you characterize a static system? Example number A, presence of memory. B, memoryless. C, depends on past and present inputs. Depends on present inputs. How can you, what could be the answer for this? Yes. B and D, right? Right. Memorylessness, you're saying it could be memorylessness and present, since it is a static system. If I redefine this to causal system, then what would be the options you would say? I think it is irrelevant, but try to map it to that. Past and present memory. See, okay. Any other answers? Anyone has any deviation from this answer? Okay. So according to this is the option based on the definitions, right? Past and present inputs. And it has memories. If it involves a past, it involves a memory. Memorylessness doesn't make sense here. Right. Other than this, any other option would fit here for causal system? can I say if a system depends on only the present input, whether it will be causal or not? Causal, yeah, right. So this option would also come. In this case, the system would be memoryless if it only depends on the present. If I'm not confusing you, let me know. So system depends only past and the present. Static will depend on only this static. If it depends only on present, then it becomes static. It's like causal and static. If it has to be inside a Venn diagram. Okay. Good. Now, okay, I was in from a mechanical system, what we saw yesterday, some examples we saw, right? So this can be force acting. If this happens again, please let me know. The spring element A K, where K is the spring constant, another where the point taken next to the stable or moving one point to another. Any you can imagine. In terms of physical thing, it is okay. How you represent the representation for this? Yes, on the spring. So I am trying to expand or I am trying to shrink it. If I'm giving a force of F, how can you mathematically represent this spring? Where it has a constant. So the force acts from here, let's take. So the simple thing is your force will be spring constant into x1 minus x2 from where it is acting, right? Okay. This is one part from the mechanical element. For example, if we have a mass and we have a one spring and we have one damping, we should know how to write this equation. So I just took this part. That's it. Okay. Now we will see another example for a static and causal system. I'm giving this example y of t is equal to u of t plus u of t minus 1 plus phi u of t minus 2. Okay. The question is whether the system is static and causal, static, non-causal, dynamic and causal, and dynamic and non-causal. How can you say, like, what option would be the correct option you think? Where y is the output and u is the input. Okay. The inputs can be split into three different parts, right? Inputs of u of t minus 1, u of t minus 2. This has become at time instant t. This is the previous instance and this one is right. So based on the definitions, static should be only present, causal should be causal can be present and past. So here present is there, past is there, past is there. So there is not, it is being added together. So only present we cannot say it has past. So it has present and past. So even if when past comes, it becomes dynamic and obviously causal since it doesn't involve any future. So if I say it has u of t plus 2, then this becomes dynamic and non-causal. Is it clear? Right. Now, I think we are clear in this part. We don't have to repeat hereafter. Good. So I'm taking just a question. Okay. I'm taking some simple RSC circuit, maybe RC circuit for now. Plus minus some V another resistor and the capacitor in series. Some current I am passing through it can be called I of t, and that's it. So how can we write the mathematical equation for this loop? Simple loop, RC loop. So I want to, since it is in series, I want to use KVL. KVL says if you add all the voltages around a closed loop, it will give you 0. That's what KVL says. Or other than that, you can say input voltage will be equal to output voltage if you see from a node point of view. Right. Now, how can I say, so when I write, when I have a circuit like this, we have orally discussed this that Monday. How can you write a signs on those things? So this already has minus and plus. So if this is plus, I have to start with plus here. Again minus. Since it is plus, it is minus here. Then I am going to follow the same direction everywhere, whatever elements I have in my circuit. Right. Now current I is passing like this because minus is flowing, minus to plus the current flows, right? So current direction will be like this. So how can I write this equation? If you add all the voltages around the closed loop, it should be equal to 0. So I am adding from the sign I have written, right? So I am starting from this direction as current passes in this direction. Here I see a minus. So I am writing it as minus V, and when I comes here I see a plus. So I am writing in terms of plus R, or for now plus VR, the voltage um, in that particular resistance. Whatever voltage it is, I am considering it as VR, voltage across the resistor. And when I comes before this element, I am seeing another plus here. So I am again putting a plus VC, the voltage across the capacitor, whatever voltage VC. So since there is no other element and the loop is open, I am going to equate to this equation. I am taking this minus V to the left hand side and the rest of the things to the right hand side. So how can I write? If I take the V to the left hand side, I will keep it as minus V equal to VR minus VC, right? So everything has minus, so it will become V equal to VR plus VC. Now, how can I write VR? Since VR is the unknown variable, I'm going to write it in terms of the known variable R. If I have a resistance value, I can substitute that and minimize this form, right? So I'm going to write it in terms of, so a voltage across a resistor according to Ohm's law measured using the current into its resistance value. So I'm going to write I into R. The I is the current that is flowing against it. And I'm going to write the voltage in terms of an integral. So if I want to write the voltage across the inductor would be L di by dt. Similarly, the voltage across the capacitor would be 1 by C integral I dt. So this becomes 1 by C into integral I dt. So this is equal to B, right? Still no stop me. So the overall circuit equation becomes I dt, right? This is what proper. So just replace this capacitance with an inductor and write your own, try writing your own equation. It will come as V equal to IR plus L di by dt. That's it. So if I put both together, everything together, how it will become? An inductor and a capacitor against it, V equal to IR plus L di by dt plus 1 by C integral I dt. Right? So sometimes in the options, you would not see any equation that has a current in it. For example, dA or I into dt. Some options might confuse you with voltage. Then again, you have to change this to the voltage form. So at that time, that C becomes V dC by dt, capacitor voltage, whatever. I think I made a mistake here. Voltage across the capacitor and voltage across the inductor, you have to write that. It's interchangeable, but based on the options, you can write whatever form you want. That's it. Then, okay. I'll take little more detailed questions since we saw some basic questions. Um, I'm considering x of t as input. I hope everybody is with me. I'm audible and everything is going fine. Right. Option A would be y of t equal to x of t square whole square. Option B would be y of t equal to t into x of t plus dx of t by dt. Option C would be y of t equal to x of t plus 1. D is y of t equal to e power t x of t. Right. It is going to be little lengthier problem. We have to solve one by one all the options using the superposition and homogeneity principle, and we have to see which one of the following systems are linear. We don't know how much it is linear. Right. So for the first question, considering y of t equal to x of t the whole square. Right. Now replace x with x1 and y with y1 and y2. So I will get two operations, right? So when I see x1 of t, that gives y1 of t, it will become x1 of t the whole square. x2 of t consider. When I add these two input, x1 of t plus x2 of t, this will become, this is like replacing x with x1 plus x2. Okay, wherever the x is there, you are going to replace that with x1 plus x2 to change the option. So if x of t the whole square is your original equations, right? If I just replace this part with x1 plus x2, how we know y1 of t is equal to this and y2 of t is equal to this. I am going to add y1 of t plus y2 of t. What it will give? x1 of t the whole square plus x2 of t the whole square. So now consider these two. This is equation 1. T plus x2 of t the whole square is equal to x1 of t the whole square plus x2 of t the whole square. Will it be equal? This is like a plus b the whole square equal to a square plus b square plus 2a. This term will be there. So the system is non-linear. The superposition itself it failed. No need of checking the homogeneity. Right. So if you don't have any doubt, we'll move to the next system. In the next system, it is y of t equal to tx of t plus dx of t by dt. Now if I replace it with y1 of t, y1 of t means wherever x is there, I am replacing it with the x1 of t. That's it. By dt. Why we are taking two systems means we want to compare two systems. We will just solve it for if someone needs help on this. T y2 of t would be t into x2 of t plus dx2 of t by dt. Now this will become t of x1 plus x2. I'm just leaving t for now since it will be very difficult to write it. Right? And this is one equation we want to consider. One equation answer we want to consider. Another one, y1 plus y2 would give me tx1 plus tx2 plus dx1 by dt plus dx2 by dt. Now, can I take this as a common multiplier? Plus d by dt of x1 plus x2. Okay, this satisfies. These two equations look same, satisfies. So, superposition satisfied. Good. Now the next point is homogeneity. Sometimes some system satisfies superposition. It can written as y. I can keep it like that or itself, right? Y equal to tx plus dx by dt. This is the actual system. I'm going to multiply it with the scalar. First, I'm going to multiply x with the scalar and replace it with x. So this will become y equal to t into ax plus d into ax by dt. When I multiply a separately with y, this will give me ay equal to a into tx plus a into dx by dt. Okay. Is this similar? Can I say it is linear? Here a is outside, here a is inside. So this we can shuffle, no? That is not a problem. But this term is outside. Can I say this is a nonlinear system? If I try to expand this, it might become differentiation of ax. For example, a equal to 2x by dt. This will be d by dt of 2x by dt. Right? sorry, the x will not come here, only 2 will come. Correct? Dx by dt, if it is okay, it's not being differentiated with the x, so it might come as like this. Right? So now we are homogeneity satisfied. Similarly, try with all these options. C, what is C? C would be x of t plus I. Do x of t plus 1. If I replace x with x1 plus x2 plus y, if I do y plus y1 plus y2, it will become x1 plus x2. So this is not non-linear. Superposition doesn't satisfy here. For D system, e power t x of t, right? This will become, if I replace x with x1 plus x2, it becomes x1 plus e power t x1 plus x2. If I do y1 plus y2, it becomes e power t x1 plus e power t x2, then it becomes e power t x1 plus x2. Right. So homogeneity satisfies. Superposition satisfies. For homogeneity, a first is e power x, second is a into e power t of x. So this will again be, there is no differentiation or anything. So the option would be, this will also be linear. Agree? There will not be differentiation, so this is also, this will be linear. So as some of you said, option B and option D are correct. For a linear system, if the question is non-linear, the A and C would be correct, but please, while attending the quiz, pay attention what the question is being asked, just because it might ask whether which of the system is linear. Sometimes it program to solve and find linear system. Somebody would tick all the linear system and go. Then you will lose mark unwantedly after solving all these things and after putting this much effort. So be careful while reading a question. These are all some twist, and I myself will design question like this. So please be careful with that. Okay, and I said like we can discuss on the week one grade assignment. 2 questions to use the simulation to get the answer. So I will design question share my screen laptop. Okay. Okay. The question has been asked like the question was like this. They consider the equation of the pendulum in lecture 5. Which of the following represents the underdamped system? Both questions have underdamped system, but the options are different, right? So when I check the equation, lecture 5, this is the equation. Since it involves all the B, we are not considering the lossless. Instead, we are considering the equation with the friction. B ml square plus this theta double dot angular acceleration, angular velocity, and an angular position, where G is the gravity, L is the length of the pendulum, and B is the friction part. We add M is the mass of the pendulum. Right. So when I designed this in MATLAB, I guess you can see the screen. So this I designed for the question 11. These are all the conditions, whatever conditions we get, I just try to automate it, but you can write one by one if you're start to learn the MATLAB. And see, this is the gravity conditions we are taking, and these are all some initial conditions I consider. We can take, I want to simulate it from 0 to 10th timestamp. So since I want to show you for a long time, like I will first show you with this and let you know what the problem is. And this is what I have written until this. The CLC clear close is for just closing all the figures and clearing the screen. This is like MATLAB inbuilt command. We can use it for our convenience. It is not related to our problem. And this figure necessarily will create an environment for figure. Otherwise, if you do only one figure, that's fine. For multiple figures, you have to mention this. And this I'm automating. I'm just giving the classes one by one. Whatever options I am getting, I'm just giving inside a for loop. For every options, it will generate a ODE, ordinary differential equations, to form the physical representation of the equation. So whatever equation, we have a second order ODE, right? This we saw now, it was theta double dot, and this is the second order ODE I'm considering. So for this MATLAB will solve that ODE if you give the equation. Here it was mentioned. This is the function I created. I'm considering theta as a first state and theta dot, that is angular velocity, as the second state. Since it is a second order ODE, there will be two states. So the number of orders will be the number of states of the system. We will study this orders and states, what is states, what is order, everything in detail in the upcoming session. Just keep this in mind. Number of order of a system will be equal to the number of states. That's it. So this represents the number of energy elements that is being there in your system. For example, if it is a RLC circuit, R doesn't store any energy, but L and C does store the energy, right? So those are the two energy storage elements. So if you write a equation, mathematical representation, you will get a second order term, x double dot, or d square by dx square x by dt square kind of term you will get, even though you have three elements, because R is not an energy storage element. Okay, similarly, we have this angular acceleration, angular velocity, and angular position, but you write those second order equation, you will get two states. I'm considering angular position as the first state and angular velocity as the second state. Okay, so this is the energy storage that lasts. Um, Hmm. So this is the last term. B by ml square is the last term I'm mentioning here as a short time notation as C. You can straight away write it here. So the theta double dot, if I take all this thing to the right hand side, I will left with theta double dot equal to minus of B by ml square theta dot minus G by L sine theta. That's what I have written here. I just rewrote this equation in a, instead of equating to 0, I'm equating to theta double dot. That's it. And I'm propagating these two states, theta dot and theta double dot, to find the theta at last. I'm interested only in theta. Right. Now, I just automated and plot the figure. You can plot it one by one and see. There is nothing fancy here. If I run this simulation, I am getting something like this, some figure like this for each and every options. For example, when b is equal to 0, m equal to 1, l equal to 1, as first condition, I am getting something like this. And for other conditions, I am getting similar figures. But if you compare these two, you cannot see much difference here. But here all the things lies to 0.5, but here it is not. Even though it is not, I couldn't visualize it properly. That's why I made this 10 to 50. So for a long time, we will run the simulation and see how well it is doing. So if I do it for 50, I'm getting, so there is a visible difference in between these, right? Sometimes we make mistakes like this. So please be careful with this. Don't reduce the simulation time and say both are oscillatory, only this another option is correct. So according to this, and before that, I want you to learn what is an underdamped system first. So underdamped systems response would look like something like this. Hmm. Right, like this. So if I start from a set point, I might go like this, and this. So it depends on the nature of the system. So I will call, if my output response looks like this, it is oscillatory at first, but at last it is going to settle. Then I can call it as underdamped system. If my if my output responses has no overshoot, but it is slowly, or it is at correct position, it is settling to the set point, then it has very less settling time, like quickly it is settling, then it is critically damped. If it is taking too long to settle, then it is over damped system. This is a general criteria we would say, but when we study about first order systems and second order system, we will see this in detail, and mathematically how will it behave, everything we will see. So this assignment is like a basic assignment for you to visualize it. So instead of going with transfer function, what we are going to learn later, I'm going to stick on to this dynamic equation. That's why I didn't use any standard transfer functions or state space here, and I just went with the dynamic equation for everyone to understand. Okay, right. Now with this, if I say what is a underdone system would be, it is like, it is oscillatory. It can be oscillatory, not necessarily to be oscillatory, but it has some overshoot or some oscillation, but ultimately it is going to a finite value, or it is going to settle to a settle near the settling point, or settle to a finite point. Then I can say it is a underdamped system. So from this figure, it keeps oscillating. Whatever time you simulate, this keeps oscillating because there is no difference in the set, like bounding value here, right? It oscillates in between 0.5 to minus 0.5 for a long time. And if you see this, for some time it is settling, but at the end of the simulation, it is going very bad. Like it is going exponentially large. This is exponentially growing. It's not settling. It's settled at first, but we are interested in finite value, right? Whatever time we are simulating, we have to see the end results. That's how the steady state value will come. Even though we are interested in transients, ultimately the steady state should settle at whatever desired value we want. So this is exponentially growing, not at all useful. So if I see this, it is oscillating, but the oscillation is coming to a constant value, to a steady state value. So I can say this is somehow useful, but this has very less overshoot and it is settling very quickly. This is also a good system. So based on this simulations, we can come to a conclusion. C and D are very useful for us. So this represents the damping nature of the system, sorry, underdamped nature of the system. So the correct option for the assignment would be, you can choose from this, right? Similarly, simulate the other four conditions for the 12th question and find what will be the underdamped system for those conditions. That's it. You just have to change here. Whatever conditions you get, you just have to change here. But be wise to change the equation if required. Right? Based on the conditions, you can get to choose this values. So that's it. I think if you don't have any doubts in your practice assignment or graded assignment anymore, you can ask some general doubts about the course, or we can wind up the session.
No, ma'am. Till now, I have no doubts.
Okay, thank you. Anybody else have it out? Code, code I can share, but I don't want to make you lazy. We have this in the video. No, try writing by yourself. If it doesn't work, I can share. Like you can ask me in that Google chat, and I can share. First, try by yourself. I want you to write. Ultimately, it's a graded assignment, right? And there is a video recorded on this. You can get help from this also. I don't want to spoil everyone who doesn't even attend the live session. So if you have any doubt, please let me know. I will be happy to help you. What is the design assignment mentioned? Okay, design assignment is a practice we used to have. We when we go around week 8 or week 9, you will study some topics like root locus, Bode plots, and designing a compensator or a controller based on some analysis tools like root locus or Bode plot. So that design assignment is based on that. Basically, you will use MATLAB to design some controller for a particular system. We will give individual systems for everyone. Whoever is there, you will get individual systems. You have to design some controller based on the specifications we give. As you go along, we would catch up on this. So that is the design assignment. You just have to submit those assignments. Like 1 or 2 questions will be there in those assignments. Design assignment 1 and 2. Each assignment will have 1 or 2 questions, and you just have to solve that and submit it along with the MATLAB code. You will be evaluated based on that. Right. If you don't have any questions, like we can wrap up the session. Thank you for joining. Thank you. Thank you so much.